Hi everyone, my name is Ramesh. I am working as an associate professor in the Department of ECE, MLR Institute of Technology. Today we are going to discuss about analog circuits course in detail. It is an undergraduate course for engineering students. Let me go on to the syllabus content first. Okay, so analog circuits course is divided into 5 chapters here. The first one is single stage and multi-stage amplifiers, and the second one is small signal and large signal amplifiers. Third is feedback amplifiers and oscillators. Fourth one is linear wave shaping and non-linear wave shaping, and fifth one is multi-vibrators. Okay, so just if you go into the introduction part, we will discuss about amplifiers and classification of amplifiers and H parameter model in the today's session. So let first unit, if you take single stage and multi-stage amplifiers. So what is the purpose of amplifier is it is used to increase the signal strength, and whatever the gain produced by the single stage is not sufficient, that's why we will go for multi-stage amplifiers. Now coming to the small signal and large signal amplifiers. Small signal amplifiers, whatever we are discussing in the first unit, single stage and multi-stage amplifier, those comes under small signal analysis. And in the large signal amplifiers, we'll discuss about 4 different types of amplifiers like class A, class B, class AB and class C power amplifiers. Now whatever we discuss in the first 2 chapters is without feedback. Okay, in the third chapter we will discuss about the feedback amplifiers. Feedback amplifiers means output is connected back to the input, that is called as feedback connection. Now what is the advantages of disadvantages of feedback amplifiers we'll discuss in the third chapter. And next comes oscillators. Okay, oscillators is an electronic circuit which produces an output without giving any input signal. Okay, with the help of DC voltage it is able to produce continuous oscillations, and those signals will be used as carrier signals in communication system. Now coming to the fourth chapter, we will discuss about linear and non-linear wave shaping. Wave shaping is nothing but changing the shape of a signal, output signal, with respect to the input signal by passing through a system. A system may be a linear system or non-linear system. Now if you take a linear system, linear systems are generally designed with resistor, inductor and capacitor elements. They are called as passive elements. Whatever the systems we are designing with linear elements, that is called as a linear wave shaping on linear system, and whatever the wave shaping we will be getting as is called as linear wave shaping. What is non-linear wave shaping is whatever the system which is designed with non-linear elements. Non-linear elements are like diodes and transistors. If you take a diode or transistor in the circuit, that is comes under non-linear wave shaping. This extensively we will discuss in fourth chapter, and we will discuss about the multi-vibrator. Multi-vibrator is another electronic circuit which is used to produce a square waveform or pulse waveforms. So this is completely extensive details related to the analog circuits course. Today we are going to discuss about the overview of the first chapter, and what are the topics we will discuss in today's session is about the amplifier, classification of amplifiers, small signal, low frequency H parameter model. Okay, these are simple basic topics which you need to understand before going into the subject. Let us move on to the next slide. So what is amplifier? This is very important, and whatever the inventions which is related to the electronic devices, the first major invention is related to the amplifier. Like amplifier is nothing but increasing the signal strength without changing the shape of a signal, and the amplifiers are designed with BJT, bipolar junction transistor, field effect transistor, and we can design the amplifiers with operational amplifiers. So we can design different types of amplifiers with electronic devices, and whatever the designs we will discuss in this particular subject are purely restricted to the BJT, bipolar junction transistor, and we will discuss extensively related to the transistor designs and how can we design amplifier. So as we discussed earlier, we have CE, CB, CC configurations. Okay, they are called as single stage, and if you can connect multiple stages, one stage connected back to the another is called as a multi-stage amplifier. So that we will discuss in first unit. We will discuss single stage and multi-stage amplifiers. Okay, if you give an input to this, let us take a sinusoidal input is applied here. Now it will increase the signal strength. What is the advantage of increasing the signal strength? For example, if you take a voice signal, my voice signal is not audible for the long distance. In that case, I need to use an amplifier. That amplifiers will be designed with the help of BJTs. It will not change the shape of a signal. It is just increase the amplitude of the signal. Okay, it will just increase the amplitude of the signal. And now coming to the classification of amplifiers, this is the basic part which we need to discuss before going into the design part. So what is classification of amplifiers? How many types of amplifiers which are possible in communication or in electronic circuits? So first one, based on frequency range. Now we have a frequency range from 0 Hertz to hundreds of megahertz or gigahertz. Now what type of amplifiers we can design on different frequency ranges? First one is direct coupled amplifier. Direct coupled amplifiers are used in the range of few hertz, or it is used to amplify DC signal. Next, audio amplifiers are used in the range of 20 hertz to 20 kilohertz. They are designed to operate in the range of 20 hertz to 20 kilohertz. And video amplifiers are used, like TV communication, we will use a video amplifiers. They will be used up to few megahertz range, up to few megahertz, 0 hertz to few megahertz range. And we have a ultra high frequency amplifiers. Ultra high frequency amplifiers are used in hundreds of megahertz to gigahertz range, thousands of megahertz or gigahertz range. And we have another type of amplifier that is called as radio amplifier. Radio amplifiers are used in radio communication, and they will be used in the range of hundreds of kilohertz to hundreds of megahertz. Okay, if you take a radio broadcasting range, it is 88 to 108 megahertz. So these are related to the classification of amplifiers based on frequency range. Next comes to the based on operation. Based on DC operating point, we have 4 types of amplifiers: class A, B, AB and C amplifiers. Now we have a characteristics, output characteristics of common emitter amplifier. If you take the load line, if you take the operating point exactly at the middle of the load line, quiescent point exactly at the middle of the load line, that comes under class A power amplifier. If you take the Q point on x-axis, that is class B power amplifier. If you take the Q point in the middle of the center of load line and x-axis, then it is called as class AB power amplifier. And if you take the Q point below the x-axis, then it is called as class C power amplifier. We will discuss about the power amplifiers extensively in the second chapter. And next, based on method of coupling. Based on method of coupling means it is related to the multi-stage amplifiers. The first stage is connected to the second stage. Through a resistor and capacitor combination. Then it is called as RC coupling. Instead of this RC, if you use a transformer in that place, okay. Instead of this, if you use a transformer, then it is called as transformer coupling. Instead of that, if you directly connect the output of the first stage to the second stage, then it is called as direct coupled amplifier. We will discuss about these amplifiers in the first chapter itself: RC coupled, transformer coupled and direct coupled amplifier. Let me go on to the next classification based on type of load. Any amplifier, if you take any amplifier, those amplifiers are generally terminated with the load. Okay. Now the load may be a resistive load or inductive load. Based on the application, we can either use resistive load or inductive load. Generally, we will use a resistive load. Instead of that, if you replace this with an inductor, that comes under inductive load. We will see the applications of resistive and inductive load in the coming sessions. Next classification is based on applications. Like what type of signals we are amplifying, whether we are amplifying voltage signals, current signals or power signals. Based on that, we have a classification and it's based related to the applications. Now coming to the tuned amplifier, which is very, very important in the communication systems, where we are amplifying a particular frequency signal. Like if you take a 98.3 megahertz radio frequency, if you want to amplify that particular signal is having a large gain. That is considered tuned amplifier. So we'll discuss about voltage, current and power amplifiers. Tuned amplifiers we'll discuss in the coming sessions. Okay, this is about the classification related to the amplifiers. Hope you understand this particular topic. Now this very, very important thing is we need to model the transistor. So as we know, the transistor is a 3-terminal device. Okay, transistor, you know, NPN transistor, it is a 3-terminal device. It has 3 terminals, N, P, N, and it has a collector, base and emitter terminal. Okay, now this transistor can be modeled as a 2-port network. So it is considered as a 2-port network and it is having pair of input terminals and pair of output terminals. V1, I1 are called as input variables. They are called as input variables. And V2, I2 are called as output variables. So we have pair of input terminals and output terminals. V1, I1 are input variables. V2, I2 are output variables. Now, we are altogether how many variables we are having for a 2-port network? 4 variables, and taken 2 independent variables at a time. That is 4C2. 4C2 combinations will get 4 into 3 divided by 1 into 2. So how many we'll get here? 6 different combinations. So there is a possibility of 6 different parameters possible for a given 2-port network. We are considering the transistor as a 2-port network and we are modeling the transistor with H parameter. So what are the 6 parameters? Are Z, Y, H, A, B, C, D. Inverse hybrid parameters are called as G parameters, and one more is ABCD parameters, inverse hybrid parameters. So altogether we have 6 different parameters. In that we will consider H parameters. Why only H parameters? Why not other parameters? Is it gives the information about the hybrid parameters of the 2-port network, like voltage gain, current gain, input impedance, and output admittance. But if you take a Z or Y, anything, if you take it, you will get only impedance or admittance information. If you take H parameters, we'll get voltage gain, current gain, which is very important for a amplifier, C, CB or CC amplifier. That's why we will consider H parameter model. Let us take H parameter model. How can we get a H parameter model for this one? In H parameter model, independent variables are, what are the independent variables in H parameter model are input current and output voltage are independent variables. They are called as independent variables. V1, I2 are called as dependent variables. Okay. V1 is equal to, okay, input voltage is a function of, a dependent variable is a function of independent variable. What are the independent variables here? I1, input current and output voltage are independent variables. Next, one more is output current is a dependent variable, which is a function of independent variables. What are the independent variables here? I1 and V2. Now we need to represent the input voltage as a function of input current and output voltage, and output current is a function of input current and output voltage. So we have 2 equations here. Okay, so we can write a H parameter model based on these 2 equations. V1, input voltage is a function of I1 and V2. The parameters are H11 and H12. And next, output current is a function of 2 variables. Again, it is a function of I1 V2, H21 I1 plus H22 V2. We have 2 equations. These 2 are called as H parameter equations. V1 is a function of I1 V2 and I2 is a function of I1 V2. So with this 2 equations, we can get 4 parameters. What are the 4 parameters here? H11, H12, H21 and H22. How to get these 4 parameters? First, case 1. By considering if V2 is equal to 0. V2 is equal to 0 means what we are doing for a 2-port network. If you take a 2-port network, V2 is nothing but output voltage. By short circuiting this particular terminals, V2 becomes equal to 0. When V2 is equal to 0 means short circuiting the output terminals. If you short circuiting the output terminals, what we will be getting here, if you took V2 is equal to 0 here, we will get H11. V2 is equal to 0. If you put it here, H11 is V1 by I1. V1 by I1 is called as input impedance. It's a ratio of input voltage to the input current. It is called as input impedance, and the input impedance is represented as HI, and it is represented, the units are ohms. Ohms means input impedance having a units of ohms. Next, this second parameter, if you take V2 is equal to 0 here, we will get the second parameter. What is the second parameter? We will get H21, which is I2 by I1. So it's a ratio of output current to the input current. It is called as forward current gain, and it is represented as HF. Since it is a ratio of currents, it does not have any units. H21 is I2 by I1, H11 is V1 by I1. So we got the 2 parameters by short circuiting the output terminals. Now coming to the case 2. Okay, case 2. Again, I will take the equations. Okay, I'll take the equations. What are the equations? V1 is equal to H11 I1, H12 V2, I2 is equal to H21 I1 plus H22 V2. Again, we are taking the equations. Now case 2, what we will be doing here is, we make I1 is equal to 0 here. If you make I1 is equal to 0 means open circuiting the input terminals. If you take open circuiting the input terminals, H12 will be considered as V1 by V2. And if in the second equation, what we will be getting, H22 is equal to I2 by V2. Now first term, if you take H1 to V1 by V2, it's a ratio of input voltage to the output voltage. It is a reverse relation. That's why it is called as reverse voltage gain. It is called as reverse voltage gain, and it is represented as HR. Next, I2 by V2 is ratio of output current to the output current to the output voltage. It is called as output. Ratio of current to the voltage, it is called as admittance. Output admittance. Okay, admittance will have a units and it is mho or Siemens, and there is no units for the reverse voltage gain because it's a ratio of voltages. Okay, now we got the 4 parameters. What are the 4 parameters? HR, H0, HI and HF. Okay, input impedance, forward current gain, reverse voltage gain and output admittance are the parameters related to the transistor, whether it is a CE, CB or CC configuration. Let me model the circuit. Let me model how can we take the circuit with the help of these 2 equations. You remember these 4 parameters: HI, HF, HR and H0. HI is input impedance, forward current gain HF, HR is reverse voltage gain and H0 is output admittance. Let me go on to the model of the H parameter model of the transistor with the equations. V1 is equal to HI input impedance I1 HR into V2. Second equation I2 is equal to HF I1 next H0 V2. So we have 2 equations here. With these 2 equations we can model the transistor, and it's very important in the amplifier analysis. First equation is a KVL equation and the second equation is KCL equation. First equation is a Kirchhoff's voltage law. How can we model this particular circuit? It's a KVL. KVL is a loop analysis. V1 and HI is the impedance. HI is the impedance and the current flowing that particular is I1. Next, we have HRV2. So it's a combination of voltages, and HRV2 is a dependent source. It is depending on the output voltage. Now how can we take a dependent source? It's a voltage dependent voltage source, HR into V2. This is input side relation and input side model. And coming to the output side, it's a KCL equation. KCL is Kirchhoff's current law, and the algebraic sum of currents entering the node must be equal to the algebraic sum of currents leaving the node. And what is the current entering here is I2 is entering, and what are the currents which are leaving here? Okay, first current. H0 is the admittance, the same representation like an impedance, and we have an output V2. H0 into V2 is the one term, and one more term is HFI1. This is the output side relation, but it is depending on the input variable. So it's a dependent source. It's a current dependent current source, HFI1. HFI1 is current dependent current source. This is the complete model of the transistor. This model we will use in CE, CB, CC configurations. So this is the input side KVL equation and it's an output side. So this is if you apply the KVL equation, V1 is equal to HI1 plus HR V2. Next, output side, if you take I2 is equal to, we can write H0 V2 plus HF I1. So this is the complete model related to the transistor. This is all about today's session. So we discussed about the amplifier, classification of amplifiers and general H parameter model for the transistor. In the next session, what we will discuss about it is H parameter model of the CE, CB and CC configuration, and what is the general analysis of the voltage gain, current gain, input impedance and output impedance of the transistor amplifier. That's all for today, and thank you for watching the video.